Hello everybody, and welcome to this video on using moles to balance equations. I'm going to start by going through an example question with you, and then after I've gone through that example question, we're going to have a look at an exam question. So I recommend that you pause, attempt the question yourself, and then when you press play, I'll show you how I'd go about laying it out. Okay, so here's our example question, and the first thing I'm going to do is analyse this question with you step by step. So I like to use bugs when I am analysing my questions. That stands for box, underline, glance and scribble. So this gives me an opportunity to really think about what it is that this question is wanting me to do. So I'm going to box my command word. I need to construct and balance an equation for the reaction. Copper reacts with oxygen, so they're going to be two important elements, to form copper oxide. There is 6.35 grams of copper and 1.6 grams of oxygen. So I've boxed my command words, I've underlined key information, I'm going to have a quick glance, make sure there's nothing that I've missed. There's no unit conversions or anything here that I need to scribble around the edges, so now I'm ready to get going. So the first thing I'm going to do is write myself a balanced equation, write myself an equation. So copper plus oxygen goes to copper oxide. So next thing I'm going to do is I'm going to start to lay out my mass first of all. So it tells me I've got 6.35 grams of copper. Okay, so I'm going to put that in. I'm going to split it into columns here. So I've got 1.6 grams of oxygen. It doesn't ask me to calculate how much copper oxide I'm going to be making or anything like that. So I'm going to leave that for now. The next thing I need to look at is the MR. Okay, so sometimes this is referred to as the mass of Mr. Mole table, because we have our mass, our MR, and our moles. So for copper, if we look it up on the periodic table, copper has a mass of 63.5, our MR. So I'm going to put that in there. Oxygen has an atomic mass of 16, but there's two of them. So I'm going to do 2 times 16, which is 32. So now I'm going to work out my number of moles. Now this is very important that in an exam, you show the examiner what calculation you're doing. Rather than just flowing through the table, doing the calculation and writing in the number, we're going to write in that we're going to do 6.35 divided by 63.5. And that is equal to 0.1. So I've got 0.1 moles of copper. Okay, I'm going to do the same on the other side. I'm going to do my 1.60 divided by 32. And that is equal to 0.05. For my final step then, I'm now going to work out what the ratio is. And to do that, I'm going to look at my number of moles and decide which is the smallest number. And I'm going to divide each one by the smallest number. So underneath copper, it's going to be a big 2. And oxygen, 0.05 divide 0.05, that is a 1. So we've got a 2-to-1 ratio here. So when it comes to balancing my equation, I know I'm going to need a big 2 in front of the copper. I don't have to put a number in front of the oxygen because it would have just been a 1. So when I do this, in order to make this balance then, if it's 2 copper going to oxygen, I need to make sure there are the same number of atoms on each side. So it must be 2 copper oxides. 2 oxygens on the right, 2 oxygens on the left, 2 coppers on the right, 2 coppers on the left. So that is the method I would use. Continuing on to our next example then,